Right, so in this video, we are continuing our discussions around LangGraph, and in this one, I want to cover the multi-agent collaboration using Agent Supervisor. So this is the end product which we will build in this video. So we have the user query, then user query comes to a supervisor. So the supervisor, if it thinks that the question can be answered using a RAG call, then it will pass the control to the RAG agent. So RAG agent will do its work, and then again it will return the control to the supervisor, right? So similarly, it has a search agent. So the search agent kind of a Tabula search agent, which will do a search on the internet, and it will give the result back to the supervisor, right? And we also have a code agent. So this code agent is nothing but a Python code executor, so which will kind of generate the Python code, and which will also execute the Python code and give us back the output. So the supervisor has all these agents at its disposal, so it can pass on the control to any of these agents, then get back the response, and if required, it will again call another agent to complete the final task, right? So we will see how this is being done. So let's go through the code. So first of all, like initialization of the keys. So one of the initialization is required for the OpenAI API key and also the Tabuli API key, right? So then we are initializing the LLM, which is a ChatGPT 4 model. Then we are kind of creating a agent function. So this agent function kind of takes the LLM, the corresponding tools that it has at its disposal, and also a system prompt, right? And based on that, it creates a agent out of it. So what it does is it uses this LangChain create OpenAI tools agent function. Then it passes this LLM tools and the prompt, and using that we get the agent. Then we convert that agent using this agent executor as a executor, and then we return that. So this return value, we will treat it as a agent, right? So then we kind of create tools which we will use during this build up process. So what we will do is we will have a Tavila search tool, which will kind of goes back to the internet, and it will do its research and then pull the data from the internet and sends back to the supervisor, right? So that is the Tavila tool, and this Python REPL tool is nothing but it will take the question from the supervisor, and if it thinks that it needs to generate certain Python code, so then it will generate and also returns back the output, right? Finally, what we have is we will do a rack setup. So in this rack setup, what we are doing is in the last few several videos, I have been using the same data source where we have two files, which are one of them is related to Japan and other is like sports. So using that, we will create a vector DB, and then we will create a retriever out of it, right? So after that, what we will do is we will create a rack tool. So this rack tool is nothing but a Python function. So that Python function kind of accepts the agent state, which we have been discussing in the past few videos. And using that agent state, it will kind of get the question. So this state is nothing but the question that is being sent using this LangGraph, and then it will do a retrieval. And once it does the retrieval and it gets the context from the retriever, and then it will like ask LLM to using this context which is being retrieved to formulate the final answer, right? So then it will return the result. So then we are using this decorator, which is at the red tool. We are converting this Python function to a tool, right? So then we will create this agent nodes. So this agent node again takes the output of state agent and the name of the tools that are available, or name of the agent that is being available. Then what it does is it returns the output as a human message with the name, right? So this is a standard way of returning the output from an agent, which also uses the OpenAI format of like AI message or the human message. So we are treating this as the agent output as human message. So that's why we are converting this output to the human message, right? So once that is done, then what we will do is we will create the supervisor chain, right? So this supervisor chain is nothing but LLM node. So it has access and information about its members. So members are nothing but the different tools or the agents that we have created. Like the members are like RAG, researcher, and the coder, right? So the RAG is nothing but the RAG retrieval, which we have converted that using the tool decorator. Then the researcher is nothing but the Tabuli researcher, which will do a web search, and the coder is nothing but the Python REPL tool, which will generate the Python code and execute the same. Right. So using this members and using the information about this members, so this supervisor chain will kind of decide which agent to run to get the desired output. And if any further calls to the any other agent is required, that will also it will decide. And if no further call is required, then it will return this finish state, right? So then what we are doing is we are creating a variable which is nothing but options, which is like finish is added to the members. So given this, so what it actually does is, given the conversation that is being sent to this supervisor, it will return back what should be the next step, right? And whether the next step is a agent call or it is kind of a finish step which will like terminate the process of executing the graph, right? Then it also has its disposal this router, which we are using this JSON object format to create a function definition, and then we are passing all this to this LLM, right? So you can see like we are passing the member informations, then we are creating a supervisor chain where we have the prompt, then we are binding the functions that are available uh, using this function def. So which is nothing but which will act as a router and which will help LLM or the supervisor to take decisions based on the messages that are available at a certain point, right? Then we are kind of parsing that output to JSON output parser, and we are creating this supervisor chain, right? And after that, what we will do is we will create different types of node. So like this is the regular stuff which we have been doing in the past video also. Like we will create agent state where we will have the messages along with also the next, which will tell like what is the next step, right? So then we are creating a research agent using this Tabulate tool, and also we are creating a research node using this func tools dot partial, where we are passing the agent node. We are using this agent node which we have created here, right? Which is a function definition which we have created here. So those arguments will be passed using this func tools, and then we are passing the agent and also the name of that particular node, right? So then we are getting the research node. Similarly, we are creating the code node and also the RAG node, right? So once all this is created, then we are kind of initializing the state graph along with the agent state. Now it will have access to the messages that is being flown across two different nodes. And then we are like adding the nodes to this workflow, like the research node, the code node, and the RAG node. And in the end, we are also adding the supervisor, right? So then what we are doing is we are creating the certain ages using this members list. So what we are doing is we are creating connections from the researcher to the supervisor to the different nodes or the different agents, and we are also creating a loop back from the agents to the supervisor, right? So which, if I go back here, so we are creating this type of ages. So one of the ages from the supervisor to the agent, and also we are kind of returning a different age which will return the output from the any of these agents to the supervisor, right? And based on this return age, the supervisor will decide like whether it should call any other agents to give the final output or not, right? So with this, we are kind of creating the edges, and then also we are adding conditional edges from the supervisor. So we are using this conditional map, which will act every members to its own name. Like if the member is like RAG, then it will map the RAG to RAG. and the researcher to the researcher, and the coder to the coder, right? So which we have also used in our last video. And then we are setting the entry point as supervisor, and then we are compiling it to create the final graph, right? So once all this is done, now we are ready to do some experimentations, right? So first of all, I am just asking it to code hello world and print it on the terminal, right? So then we are like just streaming it to see like what are the steps it is taking to complete this process, right? So first of all, it's going to the supervisor is saying that the next step is coder. So it will go to the Python REPL coder tool, where it will kind of execute the code and which will print this output, right? So, and the name, we can see the name is nothing but the coder, right? And we are in the end. After the supervisor, the control is returned to the supervisor, and supervisor is saying that the next step is finish, right? So I hope with this you are kind of getting what is the flow. Like first it started with the supervisor, then the supervisor decided that the next step is coder, and once the coder executes the code, and then it returns back to the supervisor, and supervisor kind of decides that now the whole execution is completed. So the next step is finish, right? So after that, we are passing another question, which is like what McIlroy is aiming in sports, right? So it is kind of the category of sports. So we are kind of use this system prompts in such a way that let me show you like how the system prompt is defined here. So we are kind of giving hints like use the RAG tool when the questions are related to Japan or sports category. So in using this system prompt, the supervisor kind of knows that whenever the questions are related to Japan or any sports category, so it will route the question to the agent, which is RAG call, right? So it might be the case that in your when you are building any LLM based tool, you know that certain questions can be answered better by the data that is available in your company or in your organization, right? So you kind of build that RAG based retriever, and then you are kind of using this supervisor. You are directing the supervisor to route the question to particular RAG based retrieval to answer specific type of question. See, like the at first it's going to the supervisor, then it's showing that the next step is a RAG call, then it's calling the RAG, and it's fetching the context from the vector db, and then it's creating the this final answer, and then it goes back to the supervisor, and the supervisor shows that the next step is finish, so the graph execution is completed, right? Now like few of the interesting stuff, like now we will like ask agent to take or multiple steps. So we are kind of asking supervisor to use multiple agents to give a final output, right? So what we are doing is we are asking this question like fetch the India's GDP over past 5 years, then draw a line graph of it. And once you code it up, uh, like finish the execution, right? So then the steps you can see at first it goes to the supervisor. Supervisor knows that to fetch this data, like which is India's GDP for last 5 years, it should go to the researcher, which is nothing but Tabulai search tool call. So it will goes back to the internet and brings up this data, which is nothing but the data where we have like India's GDP details for last 5 years, right? Then the control goes back to the supervisor. Uh, then the supervisor again goes back to the researcher. So researcher kind of formats that output, and then it again goes back to the supervisor. Now the supervisor thinks that I have the data that is being pulled from the internet as properly formatted data, and now I can send that data to the coder. So now the coder kind of generates this beautiful graph which shows the GDP in like last 5 years, and also it shows that India's GDP is on upward trend in the recent time. So it kind of creates the Python code using the data that is being available, and then it runs in the terminal and creates this graph using the matplotlib, right? And then it sends back the coder kind of gives back the output, and then it sends the control back to the supervisor, and it generates the final output, right? So this is how you can use kind of this supervisor agent is kind of acts as a business intelligence tool which has access to a lot of data, and then using that data it can also generate charts for you, charts or bar graphs or any of the visualization that is required to represent the data, right? So this is kind of a fully automation which you can do using this beautiful concept of a multi-agent supervisor using LangGraph, right? Now, the more beautiful example which I have, like, so we are asking this question, which is like fetch the Japan's GDP over the past 4 years from RAG, then draw a line graph, and once you code it up, just finish the step, right? So what we are doing is we are kind of asking agent to take the step, or we are asking the supervisor to first go to first go to make a rack call. So once the data is being retrieved using a rack call, then we are sending that data to a Python code interpreter, and which will generate the Python code, and it will run that Python code to generate the final visualization, right? So you are kind of creating an end-to-end data extraction logic using RAG, and then you are passing that data to a Python interpreter, which will kind of generate the output in a visualization manner, right? So we can see like this is where we have the data which is present in the RAG. So this is the source folder where we have, like, I have added this data, like Japan's last 4 years GDP. So it knows like it has the data in the RAG, so it will fetch the data from the RAG, and then it will kind of format the data, and then using that Python executor, it will create a line graph, and then it will display this beautiful image, right? So you now have this powerful tool access where uh, you have the methodology to retrieve the data from the RAG, then using a code interpreter, and then it creates a visualization out of it. So it's kind of end-to-end uh, business intelligence tools creation using this multi-agent supervisor collaboration, which we have shown in this video. So with this video, I hope you got a good understanding of what a multi-agent collaboration looks like, and how you can add a supervisor to kind of generates this data, then kind of also generate the beautiful visualization using this data. So with this, I will end this video. I hope you enjoyed this video. As usual, the code would be present in the description of this video. Thank you. See you in the next video.